that from yesterday. So the cosecant of t is going to be -5. And you're being told that the tangent of t is negative. And only from those two pieces of information, we are going to find all 6 trig ratios. So first thing I'm going to do is figure out which quadrant angle T is in. We have the first, second, third, and finally the fourth quadrants. Now, the cosecant of t is really just the reciprocal of the sine of t. So I'm going to do that as well. So that makes the sine of t -1/5. Are you comfortable with that? So I guess I should put those answers in since I now know what they are. Right, back to this question. The sine of t is -1/5, and the tangent of t is also negative. Which one of the 4 quadrants, and there's only one where that's true, which quadrant has a negative sine and a negative tangent? I interrupted you there, sorry, could you say it again? Third, let's check it. The sine is positive there, but it's negative in these two, right? And the tangent, oh, where is the tangent negative? What quadrants? All, sine, tan, cos, right? Where is the tangent negative? That was what I was asking.
4th and 2nd.
Okay, so I shouldn't have actually put those darn pluses, so I'm going back to it. Black or bluish dots mean it's right. So the sine of t is negative here and here, and the tangent of t is negative here and here. Do you see there's only one region where both things are true at the same time? And that ended up being quadrant 4. Are we comfortable about how we figured that one out? Because sometimes they just tell you it's the 4th quadrant, which is easy, and sometimes you have to fight for it. Now, since this is a sine, it's going to be opposite over hypotenuse. I don't care about the negative, we'll deal with that later. So you can build a little right angle triangle, call that T, and this will be the opposite, this will be the adjacent, and this is hypotenuse. And what you do now is you say that's 1 and that's 5. And then by Pythagoras, that one ends up being the square root of 24. Are you comfortable about how to take the sine information and build this little right angle triangle that we need? So SOHCAHTOA is going to do everything for us now. The cosine is the adjacent over the hypotenuse. And the adjacent is square root of 24, and the hypotenuse is 5. Now, in the 4th quadrant, is the cosine positive or negative? 4th quadrant, positive or negative cosines?
Positive.
Okay, so that's positive, leave it alone. Turn it upside down. There's your other guy, right? Okay, tangent is opposite over adjacent. In this case, 1 over the square root of 24. What is the tangent, positive or negative, in the 4th quadrant?
Negative.
Negative.
Right. And then you turn me upside down. And I would probably tidy these. Which ones will I tidy up? This one. So it ends up being 5 root 24 over 24. And this one, it would be negative root 24 over 24. If you're trying to tidy up, actually could probably do a little bit more, but I won't. Are you comfortable now that if I give you one of the 6 trig ratios and some type of information to tell you which quadrant it's in, that you could find all 6 trig ratios using this method. You feel comfortable with that? Right. So I don't need to do any more of them. You're happy. Okay. So a couple of questions to finish with, and then this section is over with. This is a version of question 17. And it tells us that people's blood pressure varies throughout the day. T is time. And this particular person's blood pressure is 76 plus 5 times the sine of pi t over 6. Okay. We are being asked to find out what that person's blood pressure would be at 4 times of the day. So the first one is at 8 a.m. And the second one, at least in my question, is at 10:30 a.m. And the third one is noon. And the fourth one is say 8 p.m. Time starts at midnight. So 1 a.m. is t equals 1. So this guy is t equals 8. 10:30 is actually 10.5. Are you comfortable about the 0.5? Okay. What would noon qualify as? What value of t for noon?
12.
12. And if you're thinking about the military, you should know that 8 p.m. would be what number?
20.
20. Right. You ever done the 24-hour time thing, right? So what we are now going to do is find the pressure using this formula. And it's asking you to do it to 1 decimal place. Now, the minute you see a question that says 1 decimal place, you do not need this guy over here. You do not need to tell me it's 24 root 2, right? They don't want to know that. They just want to know it's 25.123, right? So that was the clue that this question, I don't need that. I can just use my calculator, right? And what is the clue in this formula that I should be using radians and not degrees? If you look at this formula, there's a clue why I'm using radians and not degrees.
T.
Right, it's breaking up, but I think I got the gist of it. There's that pi there, isn't it, that's kind of telling you. If you see pi in the formula, doesn't it kind of mean you're dealing with radians? Right, which one of those 4 do you want me to do? Because I'm not going to do all of them because it's the same calculation. Any particular choice?
8 a.m.
8 a.m. So you want 8 a.m., you go 76 plus 5 times the sine, pi button, times 8 a.m. divided by 6, close the brackets, and the answer is, to 1 decimal place anyway, 71.7. I think they give you the units. It's milli thingies per something to do with mercury. Evidently, that's how you measure blood pressure. Isn't it millimeters of mercury in it's an old measurement. You know, a thermometer, you put mercury in the bubble and it heats, and the height of the mercury tells you your temperature. That's essentially what that is. Okay, would you be comfortable in getting the other 3? It's really just plug and chug. You got a formula, you plug in the number, you round it off. The second one is exactly the same idea, but the ugliest looking formula I've seen in a long time. This story is about a bungee jumper, and it's 100 plus 90 e to the negative t over 20 times the cosine of pi over 3t. And t again is time. And this time they give you a table. So one of the questions was, 4 seconds after the guy jumps off the bridge, what's his height? You know, in bungee jumping, you go down the wing and up down, right, that thing. So as long as I'm careful about the buttons, I should be fine. So 100 times 90 times e to the power of, see that little bracket? That's useful. The negative button, use that guy. Negative t, so 4 divided by 20 and close the brackets. Do you see how I got the negative e to the negative 4 over 20 guy? And then finish with times cosine pi times 4 divided by 3, close the brackets. If I've done that correct, enter. I did that wrong. What the heck did I do wrong?
Did you put times 100 instead of plus 100?
Thank you. You know that I knew that was a dumb answer. Agreed? In the context of this question, that guy's killed himself. Isn't he 3,680 feet under the ground? That wasn't a bungee jump. That was a suicide jump. So I knew that wasn't right. So well caught. And I did say if I was careful, and then I went and didn't follow my own advice. Now, a little bit more.
How did you copy that down? What button did you press?
Oh, you do blue button, enter. It's called entry. So second button, enter. So if you screw it up like that, that's kind of helpful. About 63 point to 1 decimal place, 63.2, and I don't know what the units are. I'm reading for them. It's in meters. Are we cool with that? So can you imagine that particular person, as time goes on, they would bounce. Well, from what I've seen at bungee jumpings, isn't there a fair amount of variation at the beginning, but then the bounce kind of drifts and all you are is dangling at the end of the rope at the end, aren't you? So I could have a guess that this rope's probably 100 meters because that'll probably end up being 0. That would be my guess. If you're interested, these kind of formulas are called damped oscillations. If you graph them, they look like this. That would be 100 feet. That's what I would expect. Are we good with this?
I got something.
You get different from me? Were you in degrees or radians? I was in radians again.
Oh, I was in degrees.
Isn't that so easy to do? I mean, because it looks perfectly fine, doesn't it? And it wasn't you did anything directly wrong. It was just, you know, radians.
I got it now.
Okay, we are good. So we are moving on to a new section then, if there isn't any other questions about what we've just done. And it's the last section for this week. So that means we're pretty much having 2 days at it. It's going to be section 5.3. It's going to be trigonometry. Can you say that one? Trigonometry. That's probably why everybody calls it trig. Isn't a hard word to say, trigonometric. So it's going to be trigonometric functions or trigonometric graphs of functions. Desmos is going to be our friend for this section. Going to make your life a lot easier. I like Desmos. It's colorful. I can see exactly, you know, what the thing looks like. And so I'm going to nip over and see if I can find some Desmos to use. Good, we're on Desmos here. Boom. Right. So we are going to look at what y equals the sine of x looks like. So we're going to do a graph of the sine function. Now, it isn't a sine function. You plug in an answer, you get a y value. You plug in another answer, you get another y value. Can you imagine that I, for the first time at least, was interested when I'm going to do it in degrees. So 0, 30, 45 degrees, 60 degrees, 90 degrees, and so on, right? Can you imagine I got a whole load of points, and then I could plot the x value against what sine of x looks like. And if I did that, this is the wrong color. This is, where's my red one? There we go. This is what it would look like. And can you pretend that the top and bottom are the same shape? I'm just not very good at drawing. This would be 0. This would be 1. This guy here would be at 90 degrees. This guy here would be 180 degrees. This guy here would be 270 degrees. And this guy here would be 360. Can you imagine you found the sine of 360 degrees? If you look up your table, can you trust me it's 0? Right. So if you plotted enough points, this is what the graph of sine x would look like. Now, it has a number of properties and terms that we use a lot. Would you agree that this function never gets bigger than 1 and never gets less than 1? But you can't find an angle whose sine is a number bigger than 1. Trust me, you pick any angle you like, keep doing it till you get bored. They never get bigger than 1 and they never get less than -1. Right? So that's the first property. Sine of x is always in the range 0 to 1. Now we call the height at which one of these curves gets to is called the amplitude. So in this case, the amplitude is 1. So far, so good. Now, let's go and do Desmos. I've got Desmos set up here. So I'm going to do y equals sine. Hopefully it knows what the sine is, and I'll tweak it so it does. Sine x. Oh, there we go. Now, do you notice it goes up? Can I make that a little bit more? Nah, I can't really do it.
You're not sharing.
I don't see anything.
Okay. I'm going to redo this guy again, out and in, and try and see if I can make this thing behave. Okay. There we go. This particular one is in radians, right? So 0 radians. See that guy there? Half a pi. Can you see that one's about 3.1? Isn't that pi? Can you see that one there? 3.2 pi, and then that's essentially 2 pi. That's what sine x looks like. I don't like black. I'm going to change the color. There, I like red. Now, if I zoom out, can you see that the sine function just keeps doing what it does forever? If I said to you, find the sine of 57 pi, wouldn't the calculator do it quickly? We wouldn't need to do all the subtraction. And you get an answer. And the sine of 492.1 degrees. The effect is that the sine function, this shape, is called the sinusoidal curve, which is a bit of a mouthful. Sinusoidal curve, if you ever see that term, it means something that looks like that. Those do appear in physics. In fact, don't sound waves look just like that? Don't radio waves look just like that? Actually, don't light waves look just like that? So there are a lot of things in the world that we deal with, right, in physics and mechanics, that have this property that, you know, if you graph them, they look like this. Now that's what sine x looks like. I'm going to put underneath it, or I will in a few seconds, cosine x. What do you think cosine x is going to look like? Doesn't it use the same kind of numbers as sine x, right? Goes up and down the same. But what will it look? What will it look like? Oh, too late. I shouldn't have typed in the extra bit. Right, let's change the color. How about blue? Right, and I'll just zoom in here. Do you see that the blue guy is in fact the same shape, but isn't it in a different position? It's been shifted. Does anybody know what that is called in physics? It does have the word shift in it. It's 2 words. Anybody heard the term? It's called a phase.
Phase shift.
That's the one. It's a phase shift. You heard that term now? Right. What that is just basically saying is that the sine and the cosine are really very similar, aren't they, in shape? It's just one's being shifted, right? Called phase shift. Do you know if you take light and you do a phase shift to it, yellow can turn into one of the other colors, right? Each color has its own wavelength, just means that, its own little thing. And if you shift them, where does that happen? Just drifting here in my brain. Do you know that they discovered the speed of stars by doing the blue shift and the red shift? You ever heard of those? And it's caused by the fact that stars are moving away from you or towards you, and depending on which direction they're going, the color, instead of being white, gets shifted into blue or into red. Useless piece of information, but it came to me, so I had to share it. So let's do some. I won't go into Desmos because I want some notes and we have to write things so that you've got a permanent copy of this. So what we've got right now is that the sine function is between 0 and 1, and that's its amplitude. So I'm going to do another guy over here. And sometimes I'll do it in degrees, and sometimes I shall do it in radians. And just getting some questions.
Is that so sine could equal 0 or 1?
Yes,
okay.
Can equal, and it can actually equal -1 as well. So here is a sinusoidal curve, which I'm going to try and draw as accurately as I can. Now, this particular curve, I won't put down its formula because that's not what I want to talk about, is if you see that place there and it gets to there, isn't that one cycle? We call that a cycle. Do you see that? And let's just say that this particular one starts at 0 and finishes at 100 degrees. Then this curve, we would say that it had a period of 100 degrees. So the period is the time or the distance from the start to the finish for the shape to repeat itself. So since I know this is 100, you should be able to predict where that is. What X value should I have at my finger now? From there to there is 100. What will that be? 200. And of course, it goes back to be the same thing. Now, let's say this particular function goes as high as 7 and as low as -7. Then we would say that the amplitude is 7. Now, the amplitude doesn't care if the number is 7 or -7. It's the distance 7 that matters. So you never have an amplitude that's a negative number, right? The amplitude is basically the distance from the middle up or down. Are we good on that? So if I give you a sinusoidal curve and the only things I asked you is what's its period and what is its amplitude, do you feel that you'd be able to see where it, what those two numbers are?
So just to clarify, the period is how long it takes for the pattern to repeat itself?
Yeah, to get back to the same position on the curve. So in this curve, you do one hill and one valley. So the period is that distance there. Okay. So that's 100. And then if you did it again, it'd be 100, right? And if I did it again, wouldn't it be another 100? Mm-hmm. Right. So when you look at sinusoidal curves, really all you need is a building block. Don't you just need that? And then you know it's going to do that forever. And so what the period tells us is how far to go from here to here, right? To start and to finish at the same point. In fact, I could do it from here to here. Wouldn't the distance from here to here also be 100 degrees? So let's do just one more of those to be convinced, you know, that we're getting this across. I'm going to do a sinusoidal curve. I'm just going to have it start up here, something like this. And I'm going to be a little bit sneaky here. Let's go for the easy one first. For this trig curve, the sinusoidal curve, what is the amplitude?
3.
You agree that's pretty easy to tell in this kind of situation. Now, being a little bit sneaky on the period. Pick any point you like on the curve and then find another point that's the same place and the
80.
distance between. Say again?
80.
80? I'm not sure where that came from.
Is it 40?
Do my things like zeros? God, that's bad. They're meant to say pi, 2 pi, 3 pi, 4 pi, and 5 pi. Did they look like 50s and 40s? I apologize if they do. Okay. Those things that look like zeros are pi symbols. Okay.
So would it be 2
yeah,
pi?
that's
Would
what I
it
was
be
thinking.
pi over 2?
Nope.
It would be 2 pi, right?
Yeah.
Nope.
I
Wait,
thought
what?
it was 4 pi.
I thought it was 4 pi
Pi?
too.
Pi.
Yeah,
It's-
here we go.
2 pi.
From here to here. Isn't that the start of the shape and then it goes back to where it began? And that distance starts at 0 and is 4 pi. That is the period. Right, we need to do another one of these and I need to draw much more carefully. I'll do them in red this time. So that's 0. That's 1/3 pi. This guy is 2/3 pi. This is pi. This one here is 4/3 pi. And this is 5/3 pi. And this here would be 2 pi. Same question as before. You're going to be asked to find the amplitude and the period. Okay, I'm going to do the amplitude myself because hopefully that's the easy one. Now, the period is pick any place on that curve you like and then find out further along to the right where it happens again, right? And the distance between the start and the finish is called the period. Me personally, I tend to start at 0 because it's easiest.
So would that be 4 pi over 3?
Correct. Would you agree that this point ends up going to there? Pick tops of hills, bottoms of valleys. That distance is called the period. And from 0 to 4/3, that's another reason I picked 0. Isn't it easier to calculate? Right, because when I'm 0, and you just need to write down what the second one is. Right. Are we more comfortable about the period now that we've seen a couple more? Right. I don't think would you agree the amplitude has not been a problem right now? So we are looking at lots of different situations on what the period and amplitude are. And the only ones we've done right now are ones where you're given a picture. So now we're going to move to how to get that same information when they give you the equation. So this is an example of question 2. And the amplitude is going to be this number here. So if you do 2 sine something, 5 cosine something, 3 sine something, minus 2 cosine something, this constant, right? This big number at the beginning, before the cosine happens or the sine, this number is your amplitude. And you can check that. Can you put that into Desmos and say, oh yeah, it goes up to 3, it goes down to -3. Right? Pretty easy to check. The second is the period. Now, if we want the answers to be in radians, we have one formula. And if we want the answer to be given in terms of degrees, we have to do a different formula, right? So you take 2 pi and you divide it by that number. Oops. Let's write that again. Yeah. Does that look more like an 8? Because it kind of gets squished. 2 pi divided by that number. This is a quarter pi, or if you prefer, pi over 4. Now, if you want to do it in degrees, because maybe the answer for the formula in degrees, you still divide by this guy, right? So if this is 3, you divide it by 3. If this is 10, you divide it by 10. So 360 degrees divided by 8. And the answer, if we do 360 divided by 8, is 45 degrees. So if I know I want the answer in radians, we do this. If I know I want the answer in degrees, we'll do this. This is 3 cosine 8x. I can now do a very simple sketch of this guy. Cosines always start on the y-axis. So cosines always look like that. At least that's how they start life off. Sine functions always start like that. So if I want to do a sketch of 3 cosine 8x, I would simply say, okay, where do I start? Since it's a cosine, I start here. And then I can basically just try my best to draw a shape that looks like that, right? That's one cycle. Now, since this is 3, that's 3, and that's -3. Since the period is a quarter pi, won't that guy be a quarter pi? Are we good so far? I've just basically done a very, very primitive sketch of 3 cosine of 8x. I'm going to do a little quick calculation here because I want to check this. That number is roughly 0.79 radians. I'm going to nip over and do Desmos. With a bit of luck, Desmos is going to agree with me. So where are we? Basic on here. So it's y equals 3 cosines of 8x. Okay, don't worry about the weird shape. I think I can make x nicer numbers. So let's do from 0 less than or equal to x less than or equal to 0.79. Oh, right. Can I change the scale in that? I'm not sure I'm convincing you, but actually that is the sine function. I just have to figure a way. Does anybody know how to change the x scale so it shrinks in a bit? Because when you do the mouse pointer, it shrinks in both directions, and I just want it to shrink in one direction. Does anybody know how to do that? Okay. Well, you do one of those things we do in chemistry when I tell you it's going to be orange and it looks like red. And then I say to you, if you look really carefully, can't you see that it's orange, right?
Can you change it with the wrench over to the right with the plus and minus button?
Oh, I like your thinking. So I'm going to do 0. And what was that guy, 0.79? Oh, you good. You get your 10% back, Jason. But if you look at this guy, doesn't he look exactly like the guy I did the little sketch of? So do you see my formula do work, don't they? That is cool. Now I know how to do that. Thank you. So if you wanted to find the amplitude and period of a function, you can simply just amplitude is this number, and period, you get it by dividing by that number. Okay, let's do some examples of that without all the pictures and so on. That kind of slows things down. So I'm interested in this fella. And this one. And this one. And lastly, this one. And I'll do some in degrees and some radians. So here we go. What is the amplitude of this first one? I'll call them 1, 2, 3, 4.
10.
Right. What's the amplitude of this one?
3.
Yeah. Don't care, it says -3. Amplitude is 3. And from completeness sake, this is 2 and this is 4. Right. If you want to know the period of this function, if it's in degrees, it's 360 divided by 2. This shape will repeat itself every 180 degrees. That's all a period is telling you. How many degrees till it repeats itself. If you do this one, but let's say you want the answer in radians, it's 2 pi divided by 5. So this shape will repeat itself every 2/5 pi radians. This one, let's say it's degrees again, it's going to be 360 divided by 1/2. So this shape will repeat itself every 720 degrees. And lastly, this one, let's do it in radians. Do you think the negative matters, or do you think it's only the 3 that really matters when we talk about periods? Think about amplitude. Isn't it just the 3 that matters? Amplitude is a positive number, period is a positive number. So if I give you any sine or cosine function, do you feel you can tell me the amplitude and the period without too much work? Do you feel comfortable about that? Right, that's good. Now, suppose you get a question and the question asks you to sketch it. And me personally, wouldn't you probably go to Desmos and do it? And now that Jason has shown us how to play about with the window, we can make it look correct. But I'm going to do one more, right? Where we'll do say this one, right? And we'll see if we, well, I want to do this one. Yeah, I'll do this one, it's easier. Right, numbers are nicer, I mean. Right, so we'll take this one, right? And we'll imagine what it would sketch like. So 10 the sine of 2x. It's a sine function. So don't sine functions start at 0. And they go up and they go down by the same amount, and then they end up back home. Now for this function, since the period is 180 degrees, won't that be 180 degrees? And this is 0 degrees. And since the amplitude is 10, won't this be 10? And won't this guy be negative 10? You agree? Now, can you imagine a question that asks you for the amplitude in radians and then the sketch, right? That would be it. If they asked you the same question, but they wanted the answer to be in radians, wouldn't the only difference be that that would be pi? Okay. Let me show you then some of those questions in the homework, just so you can get a feel for what they look like. And there we go. Right. Are you looking at 5.3 trig graphs? Is that what you can see? Okay. Right, here's a guy. Find the amplitude and period, and you see it's got a little negative there. What do you think that negative is going to do to the shape? Because one of these 4 shapes is the right one.
It flips it upside down, right?
Yeah. So won't you be looking for, what would that be? A period of 180 degrees? Oh, it'd be a period of pi because it's in radians, right? So that one's no good, and that one's no good. And then this puts it upside down, would get you that one. Wouldn't the simplest way to do that would be just to put it into Desmos and look at your picture, and then look at these 4 guys and see which one it was. So, I mean, Desmos is going to make your life so much easier, right? You may have to do a little Jason's technique because it might be quite crunched, you know how that's just the way it is. So if you go and hit the little, look like a wrench, a little wrench symbol, we should be able to change that. Actually, since that's here, right, let's do that one. Negative sine of 2x. Right, can I find Desmos? Can you see Desmos right now? Or will I have to go in and out?
Yes.
You can see Desmos, okay. So I'm just going to clear this one out and put in y equals negative the sine, I believe it was 2x. Right, and then the period was what again? It was 0 to pi, wasn't it? So 0 less than or equal to x less than or equal to the little curly brackets. And I forgot to put in pi here. No, is it pi? The little baby pies. There we go. Right, now if you look at this shape, can you see it's kind of hard to see because of the vertical scale. So we'll hit this guy, and we know this guy goes up to, what does he go up to? Well, 1 and negative 1. So can't I just go to the y values and put negative 1, and over here put 1, and yay. Didn't that look pretty much like the shape we saw? And then you could go back and look at your 4 pictures. So if they say to you what shape, you know, if they give you a picture, can't you just use Desmos and a little bit of tweaking? Right. Okay, let's just play about with this one a minute. If I make this, let's put that one in for a second. And suppose I change just one thing. I'm going to be writing negative 3 here. Can you see the effect that has is all on the amplitude? You see it has the same basic start and finish. Doesn't it cross the x-axis at all the right places? But it grows vertically. Isn't it a bit like somebody, right? And one more of these guys, why don't I take this guy? Well, actually 2 more. I want to do 2 more things. Let's suppose I take that guy and I make this fella 0.2. Can you see the opposite effect. Aren't I basically like sitting on it and crunching it? So the amplitude is to do that. You probably, well, you might know about this. Do you know when you have AM and FM on your radio? AM stands for amplitude modification, right? Amplitude. They send the radio waves, and the change in height is how you find out what the sound is. So it's coded by the height of the wave. Now, the other is called FM, and that's frequency modulated. And in a frequency modulated signal, the height is the same, top and bottom. All they do is they keep changing the frequency, which is basically how many cycles a second. So they crunch it and they stretch it. So these things do get used in science. And I am now going to leave this guy and do another one of his examples. So here we go. This is a version of, I think it's question 3. Yes. We are being asked for the amplitude, and it's all in radians, the amplitude and the period of this function. Are you happy with it's a quarter? And since it's radians, it's a half pi. That's how easy that question is. Hopefully that's how easy it is to you, right? And then plug it into Desmos and you can see some pictures and you pick the right one. This one might catch you, I don't know. This is a version of question 4. The amplitude is 2 and the period is 2 pi divided by what? What number, what term should I divide this guy by?
Pi.
So in this case, doesn't the period come out as a nice number? In fact, if I wanted to sketch that without Desmos, I would be saying to myself, turn me upside down. Right? So the amplitude is 2 to negative 2, but instead of going up, turn me upside down. And wouldn't that guy be 2? Would you agree that's a very primitive sketch, but that's what that guy would look like? If all you know, you don't need to know an awful lot to sketch a trig function. Don't you kind of need to know amplitude and period? If you tell me those things and then, factor in this fact that this is turn me upside down reflection in the X, you are good to go. Are we good so far? Have I covered amplitude and period to the point where you feel good? Right. So for the last part for today, we are going to do phase shift. Imagine that you have your untouched sinusoidal curve, right? The guy that looks like this. A phase shift is essentially where you take the same curve and you shift it either to the right or to the left. In this case, I've shifted it to the right. When you look at a function, a trig function that's had a phase shift to it, this is what this guy looks like. Now, what has happened to this shape is that the original black one, would you agree it's been shifted to the right? And that number there is 30 degrees. So in this case, do you see how it's been shifted to the right 30 degrees? We call this the phase shift, PS for short, and it would be 30 degrees. Now, if it's in radians, that's fine. Similar thing. So start off with our normal sinusoidal curve. And it's going to be shifted, say, to here. And I tell you that this guy here is, say, 2/3 pi. This fella is sine x. The phase shift will be the sine of x. Take away how much you move it to the right. Are you surprised that that's a take away and not an add? Right? It's a subtraction and not an add. Is that surprising, or is that what you thought it should do?
Seems a little backwards to me.
It does, doesn't it? You know, you're moving something to the right and it's subtraction. So let me kind of tell you where it comes from. Way back in 141, which hopefully wasn't that long ago, can you remember moving transformation of functions? You remember y equals x squared? If I took that guy and I moved it to the right, say 2 units, wouldn't the function for that guy be x take away 2 squared? You remember that? If you move something to the right, you get that. That didn't help as much as I thought. Have you done transformations? You should have seen them. Maybe you've forgotten about them, but you did see them. So it's the same reason, right? If you move something to the right, that's essentially what happens. So what would this guy look like? There's my original sine curve. And this time, I'm going to take my shape, right, and I'm going to shift it to here. And this guy starts life there. If you shift something to the left, how does that affect this equation? Any thoughts?
That'd be x plus pi over 4.
Yes. So we basically only got 2 directions. Can you phase shift it right or phase shift it left? When you phase shift it right, you move the curve to the right by whatever they tell you. And in this case, it's 2/3. That's your formula. If you shift it to the left, do you see that the formula, and I kind of, if that means right, wouldn't that have to mean left? Would you agree? You'd have to do something different, right? So if you know that that means right, you're probably going to figure out that that means left. Are we good? So are we comfortable at least what phase shift looks like? Right. And write that one down, because it has another name that you're going to see. I don't like this name because that's the name you're going to see in physics and chemistry when you actually do stuff with this. Horizontal shift, I think it makes more sense, isn't it, moving it horizontally? So I guess that's why they also choose that name. They are the same thing, right? So horizontal shift is the same thing as phase shift. But phase shift is more realistic in the outdoor world. Okay, here's just 4 sinusoidal curves. I'll go through the easy one first. Amplitude 3, amplitude 4, amplitude 1/2, amplitude 2, right? Got those questions out of the way. I still like phase shift, so I'm going to keep calling it phase shift. And you just remember that they'll ask you at least sometimes they're going to ask you, they're calling it horizontal shift. 70 degrees to the left or 70 degrees to the right?
To the right.
Right.
Okay, so we're going to just write it down in English and then tell you how you write it down in the homework. Pi upon 2 left or pi upon 2 right? What's the phase shift look like?
Left.
Left.
Agreed. Once you've seen a few, does it get a little bit more comfortable? You're just getting used to what they do. Right, what about this one? Left pi upon 3 or right pi upon 3?
Right.
Agreed. And then to finish with this last one, left 50 degrees or right 50 degrees?
Left.
Right.
Oh, I get 2 answers. You want to change your mind, either of you? Left or right 50 degrees?
Left.
Agreed. Yes.
For
Now,
me,
it
it's
would be.
always the opposite of what I think of. When I think of 50, you think right. Or
I
plus
know
50.
it is kind of back to front, isn't it? But you just have to live with it. That's actually, if you put that in to Desmos, you will see the sine curve move to the right 70 degrees. Trust me, it does it, right? It does exactly what it should do. Even if it looks back to front, it is a shift to the right. But you do not write down right 70 or left 70. What you do instead is call that 70, and you call that negative pi upon 2, and you call that pi upon 3, and you call that negative 50. So when something is positive, right, if someone says the phase shift is 50 degrees, that means move it to the right 50 degrees. And if they say the phase shift is negative 50, doesn't that mean move it to the left 50 degrees? So you won't be using the words left and right. You will be using just the values. And isn't it that back to front thing? Take away plus answer. Add negative answer. Take away plus answer. Negative, plus negative answer. You see that back to front thing happening all the way through? So when somebody says, what's the phase shift? Although you might say in English, I'm moving it to the right 20 degrees, shouldn't you just say 20 degrees? And if you say, oh, I'm going to move it to the left pi, you should say phase shift is negative pi. Okay, so as long as you got that left, right, back to front thing that's going on, you'll be fine. And time to say your last name and bye-bye for today. And my earphones lasted, which is great, because I thought I was going to...
Yay!
What was that, Ali?
I said, yay! Could you hear that?
Oh, God, I think my left ears went deaf now. Okay, I'll hang about for any questions, and otherwise I'll see you tomorrow.
Thank you.
Okay.
I had
Yes,
a question about the homework.
Sure, which one?
So for 13 on the trigonomic functions of real numbers.
Okay, I found that. Could you give me the question number again?
It was 13.
13, right, okay. Okay, it's middle to end. Right, and the guy I'm looking at here is rewrite the cosine of t in terms of sine nt and sine tn or something, right? Or they're just telling you how to write it down in WebAssign. Okay. So what do we know? We have to take the first guy, which is cosine t, and we're being asked to write it in terms. So it means write it using sine t. Okay. Can you remember we did a formula that basically started off as sine squared t plus cos squared t equals 1. And then I rearranged it to do that. And then you take the square root of both sides and you end up with that. And we talked about there are two possible answers. It depends on which quadrant the angle T is in. In this question here, the one that you've got, at least the one I'm looking at, it was in the third quadrant. Was T in the third quadrant for you as well?
For me, it was in the fourth quadrant.
Okay, so in the fourth quadrant, all sine, tan, cos. What is the cosine in the fourth quadrant?
Negative.
Look again.
Oh, with fourth, yeah, sorry.
Right. So the answer that you would write down, if you were doing it on paper, with that. The little bit at the top, they're telling you is that WebAssign doesn't know how to write that, I guess. So you do bracket, the sine, bracket T, close the bracket, squared. And that's how you write this down in WebAssign.
Mhm.
And I don't know if that was the problem, that you couldn't get WebAssign to understand what your answer is, even although it was that answer.
So I just submitted it, and the problem was that for some reason I was sure that it was negative in the fourth quadrant.
Ah, so you just took the negative version, not the plus, and that's all. Well, that's
Yeah.
a different mistake, but you fixed it, right?
Mhm.
Oh, so did you write it this way?
Yes.
Ah, okay, so yours was a little careless. That was all.
Yes. All right. Thank you.
Okay.
Yeah. And I did have questions about the last two, but I think the problem is just that I did in degrees instead of radians. So
Okay, that might help.
yeah.
So from what I can see, they seem to prefer radians almost exclusively now, with only now and again degrees popping in. Is it